Okay, so our summary of Chapter 3 for derivatives. So remember that the definition of derivative says that you can find the derivative using the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so this is the definition of derivatives. And this, of course, will give you guys the slope of the tangent line. So f prime of x is the formula for the derivative. So whenever you see f prime of x, it's the formula for the derivative. So I'm not really going to go over this too much, but using the definition of derivatives, let's find the derivative of f of x equals x squared minus 3 and x equals 2. So basically, just using that notation, the limit as h approaches 0 of f of x plus h, I don't know why I'm rewriting it, but we will, over h. So here, f of x plus h, that means wherever there's an x, instead of x, I'm going to plug in x plus h squared minus 3. That's my f of x plus h, minus the f of x itself, which is x squared minus 3, and all of that is over h. You FOIL this out and you simplify it, and you will end up with a function, and then you can plug in the 2. Okay? So just keep in mind that if you do have the definition of derivatives written out like this, you can see that this part right here gives us our actual f of x function. Alright? Alright, the different techniques that we learned: power rule, product rule, quotient rule, chain rule. So I'm not really going to do all of these, but for each and every one, you can see here that you can use the power rule. Because what is the derivative? 7x to the 6th. This one right here, before I write the derivative, you probably should have done this first. Let's rewrite it in a way that makes it easy for us to use the power rule. Okay, so it's 7x to the 6th plus, what's the derivative of x to the negative 7? So it's negative 7x to the negative 8. What's the derivative of square root of 7? 0. What's the square root of 1 over pi? 0, because that's just a number. And then you rewrite this without any negative exponents, so 7x to the 6th minus 7 over x to the 8th. And if you, then you can just leave it like this. Alright, so for this one, you're going to be using the chain rule, because there's an inside and an outside. So remember, it's basically the derivative of cosecant of the stuff times the derivative of the stuff on the inside. Or you can make your in and out chart. So my in is 2 over x. My out is cosecant of u, if this is u. Find the derivative, and set it up. Alright, for this one, what would we use? It's the product rule, because it's two things being multiplied together. So product rule says you take the first part as it is, and you multiply by the derivative of the second part. So the derivative of 1 is 0, the derivative of negative x is negative 1, the derivative of negative 5x squared is negative 10x. and then you add the second part as it is times the derivative of the first part, which is 12x minus 0. And then you would clean this up. So we FOIL this part out plus the FOILed this part out. So this actually ends up being negative 6x squared, negative 60, no, 6, sorry, negative 6x squared. The outer is going to be minus 60x cubed, the inner is going to be plus 2, and the last will be plus 20x. And we add the FOILed out product from this, and this is just 12x minus 12x squared minus 60x cubed. And you continue cleaning this up, and you would combine like terms. Okay, I'll leave that to you guys. Combine your like terms, and you'd end up with your final answer. And that will be your y prime. Okay, moving on. Again, this is going to be the chain rule, but multiple times. Right? So remember that this 9 is the same thing as saying tangent of 7x plus 3. All of that is raised to the 9th. So here we have an inside function, another inside function, and then we have the outside function. So starting with the guy that's on all the way on the outside, we take this 9 and we bring it down. So this becomes 9, and then the inside, remember, stays as it is, and this becomes to the 8th, times the derivative of the inside. Oops, sorry. So that's the derivative of the inside. And again, in the derivative of this, you're going to take the derivative of tangent, which is secant squared. Am I right? So secant squared of 7x plus 3 times the derivative of the inside, which is just 7. Okay? And then we can clean this up if we can, and really the only thing that we can do to clean this up is multiply the 9 and the 7. And remember, you can still do the in and the out. So here, the inside at first is, let's let u equal tan of 7x plus 3, and the out is going to be u to the 9th. And then you take the derivative of this, but to take the derivative, you have another in and out. Okay, and then you take the derivative of this. Alright, for number 5, the first thing that you're going to do is write it in a way that you can actually take the derivative. Or you could use the quotient rule, but I think it's going to be much easier to just write it in the numerator as negative 3 halves. And now you can just use the chain rule. And the chain rule says, take this, bring it down, so it's 3 times negative 3 halves times the inside as it is, times the derivative of the inside, which is going to be 10x plus 2. And then when you clean this up, you got negative 9 halves, 5x squared plus 2x, times, sorry, I forgot to put that in parentheses, times 10x plus 2, and you can FOIL this out. Basically FOIL these two parts out and then distribute that negative 9 halves to end up with your y prime. Alright. Okay, so here there's a lot going on. So this first part is product, right? Because you got t times inverse secant of t. And the second part is your log. So you got half ln of t. So this first part is product. And then the second part is log. Aren't you supposed to be in the AP exam? No. All right, number 7. And remember, what is the derivative of ln of t? It's going to be 1 over t. So what's the derivative of half ln of t? Is going to be half 1 over t. Because you can do the product rule here between the half and the ln of t. All right, number 7. e raised to the inverse tangent. So the minute that you see a function in the exponent, you're going to use the log derivative technique, which basically means if it's e to something, you would just take the ln of both sides. So this becomes ln of y equals ln of e to the inverse tangent of x. And what that does is it allows us to bring down that exponent. So this becomes ln of y equals inverse tangent of x. And ln of e is just 1. So side note, ln of e is equal to 1. So really we can just cancel that out altogether. And then you derive both sides, and you get your dy dx. Okay? So take the derivative of this side and the derivative of this side, and the derivative of ln of y is going to be 1 over y times dy dx equals the derivative of inverse tangent, which is going to be 1 over 1 plus x squared. Okay, and then you solve for dy dx, and remember to plug in what your y is back in. So let's just really quickly do this one actually. So keep going. You get dy dx equals 1 over 1 plus x squared times y. But instead of the y here, I'm going to plug in my e to the inverse tangent of x over 1 plus x squared, and that's my dy dx. All right, part 2 in a sec.